Hey guys, we are finished with our notes officially. The rest of the video I'm just going to be working through the AM support practice worksheet just so you guys get some extra practice in on these word problems. So notice they have the equation at the top for distance problems. So distance equals rate times time. What that's the same as is I told you guys speed equals distance over time. That's the one I prefer to use. Sometimes people refer to it as, instead of speed, a rate. And notice if you were to like solve for distance in my formula, you would do times t times t. So instead of like speed times time, they're calling it a rate times time is distance. I like to think about it like my formula because I think it's a little bit more intuitive to think about like a speed of a car as a distance over time. So I'm going to be using my formula. If you prefer the formula at the top, you're free to use that one too. Okay, so some of these will be like the ones that we saw yesterday where we had like a pretty standard path to follow with our steps. Some of these will be a little different, so the key is to always like start with your formula and see what you know and what you're looking for. And then that kind of dictates how you solve the problem. Okay, so number one, Aaliyah is making a trip to the recycling plant and back. So I'll do like maybe there and back, right, to keep track of my information. On the trip there, she traveled 25 miles per hour. And on the return trip, she was only going 20 miles per hour. And then here's what they're asking. How long did the trip there take if the return trip took 5 hours? So we want time here. This one was 5 hours. Okay, so let's plug stuff into our speed equals distance over time. So going there, her speed was 25, and that was equal to a distance over a time, and we don't know the time. On the way back, her speed was 20 miles per hour. That was equal to distance over time 5. Now this one, the two things we don't know are the distance and the time specifically there. However, if she's going from one place to the recycling plant, right, she's going there and back, the distance is going to be the same, right? If it's 5 miles there, it's also 5 miles back. So what I'm going to do is I'm going to solve for D. So times T times T. So 25T equals distance. If I did it on the other equation, times 5 times 5. D is equal to 25 times 5 is 100. And then the trick is, if it's the same distance, I can set these two equal. So that means that 25T is equal to 100. I'll kind of fit it in here. 25T equals 100. So T equals 4 hours. Okay, and so that's really just going off of kind of a substitution idea. Right, you're saying the distance is the same, so you can kind of set the rest equal to each other. Number 2, a diesel train left Sewell and traveled west at an average speed of 85 miles per hour. Okay, so 85 miles per hour going west. Sometime later, a freight train left traveling the opposite direction at an average speed of 45 miles per hour. So I'm going to maybe do diesel and freight. Seems like the easiest way to split up my information. So diesel is going west, 85 miles per hour. The freight train is opposite, so I'm going to say east, 45 miles per hour. After the diesel train had traveled for 16 hours, so 16 hours, the trains were 1,945,945 miles apart. Find the number of hours that the freight train traveled. I'm going to scooch this over here just so I have some space. Okay, so let's get a picture of this maybe. So they start, so a train, this is my diesel, is traveling west, and it's going 85 miles per hour. And sometime later, a freight train traveling in the opposite direction. So the freight train is going this way. Okay, and at some point, the diesel and the freight are 1,945 miles apart. And we're looking for hours that the freight train traveled. Okay, so let's see. If the diesel train is going west and they are going 85 miles per hour for 16 hours, we could take this information and say, okay, the diesel is 85 miles every hour for 16 hours. And if I do on my calculator 85 times 16, that tells me it's gone 1,360 miles. So like from wherever they started, it kind of sounds like we're assuming that, maybe they started at the same place, maybe not. But regardless, wherever the diesel train started, it's gone that many miles. So the diesel train, it looks like it's accounted for 1,360. If I subtract that from 1,945, what's left is going to be, looks like 585 miles. Okay, so that's how many miles that the freight train has gone. And if the freight train is going at a speed of 45 miles per hour, we can use our speed equals distance over time equation. So I know speed equals distance over time. The freight train speed is 45 miles per hour. The distance is 585. And if we divide by time, we're going to be solving for time. So you can treat the solving here kind of like cross multiplying, right? If I think about it as 45 over 1 is equal to 585 over t, you're going to get 45 times t is equal to 585. If I do that divided by 45, looks like my time was 13 hours. Okay, so this one's a little bit hard unless you draw a picture. It's a little bit different than the ones that we've done more in class where you have to do more, just like make your list, do your system of equations, and so on. So number 2 is like a little harder to do without a visual, I would say. Okay, let's see some more. Next one is Joe traveled to his cabin on the lake and back. Okay, took 1 less hour time to get there than it did back. So let's do a there and a back. We're going to keep our information in a table. Okay, so it took 1 hour less to get there than it did to get back. So I'm going to call back time, and going there it was time take away 1 because it was an hour less to get there. The average speed on the trip there was 30 kilometers per hour. The average speed on the way back was 20 kilometers per hour. So it looks like there was 30 kilometers per hour, back was 20 kilometers per hour. How many hours did the trip there take? Okay, so this one's a little bit trickier because of how you have to write the time in relation to the other time. I would say that's kind of the hardest part about how to set this part up. This one's also really similar to the first one we did, where you have to assume if the distance is the same, you can use that to help you. So if I was doing my speed equals distance over time, and I'm looking for hours did the trip there take. If I was using my speed equals distance over time, going there, my speed is 30 kilometers per hour. That's equal to a distance over time minus 1. Similar for this trip back, my speed was 20. That's equal to a distance over the time t. We don't know either the time or the distance, so you could do 2 things. You could solve as a system of equations and like formally write it out and do substitution and elimination, use the matrix. I'm going to do something similar to what I did up above here, where I solve for d and set them equal. So if I look at the first one, solve for d, I'm going to get d is equal to 20t. If I solve for it on this side, I'm going to do times t minus 1 on both sides. Make sure you keep parentheses because you want to do t minus 1 times 30, so you're going to have to distribute. So 30 times t minus 1 is equal to d. If I set these two equal, I get 30 times t minus 1 equals 20t. Distribute, you get 30t minus 30 equals 20t. If I get all my t's on one side, I'm going to have 10t equals 30. Looks like t is going to be 3. However, let's look back. I called my time t, amount of time it takes back, which was 3 hours. Notice they asked us how many hours did the trip there take. So you want to be careful to reevaluate what they asked for. So there was 1 hour less, so that's going to be 2 hours. Okay, let's try number 4 now. Number 4, Stefan left school 3 hours before Joe. If you're like me and you're into TV shows, the first thing you probably think of with Stefan is probably the Vampire Diaries. There was a time that my little sister was very obsessed with Vampire Diaries. So if you're looking for, a binge-worthy show, Vampire Diaries, I think, is like 7 or 8 seasons long. So feel free to take that as a suggestion while you guys are doing a lot of TV watching, I'm sure. But make sure you guys go outside, get some air. So Stefan left school. I'm going to put school here. They travel in opposite directions. Jill traveled 53 miles per hour for 1 hour. So if she went for 1 hour at that speed, that means she went 53 miles. I hope Jill is traveling in a car. That sounds like a really sad walk. I don't think you could run that fast. After this time, they were 277 miles apart. What was Stefan's speed? Okay, so let's see. If they're 277 miles apart, I know that the other distance has to be pretty significant, right? So if the total is going to be 277, I'm going to do 277 minus 53. Okay, looks like it's 224. So Stefan went 224 miles, which means he either traveled by car or he used his freaky vampire speed to run really fast. Let's see. So from here, we want his speed, and remember it was after 1 hour that Jill got that far away. So if I went 224 miles, pause, I missed something. Stefan left school 3 hours before Jill. So Jill has traveled for 1 hour. That means Stefan has traveled for 4 if it's 3 hours in addition. So 4 hours, 224 divided by 4. Looks like we're going to get 56 miles per hour. So he's actually not going that much faster than Jill if you compare, keeping in mind the time. Okay, so that's the last of our speed, distance, time problems. We've got some mixture problems. I would say like the wind, current, those are also good speed equals distance over time problems. So let's take a break and do a little bit of mixture, and then we'll come back to our speed, distance, time problems. Okay, so first one says a metal alloy weighing 1 milligram and containing 80% platinum is melted and mixed with 7 milligrams of a different alloy, which is 16% platinum. What is the percent of the resulting alloy that is platinum, I think they mean. Okay, so let's see. We know we take 1 milligram, and I'm going to keep it color-coded. So the 1 milligram is 80% platinum. So if I do the 1 milligram times 0.8, that will tell me how many milligrams are pure platinum. And it looks like it's mixed with 7 milligrams. And I'll try and keep it color-coded. Sorry about that, guys. I'm going to switch color here. 7 milligrams, that's 16% platinum, and they want the percent of the resulting alloy that is platinum. Okay. So we're kind of looking for, let's see, we know that it's going to add up to be 8 milligrams. We want to know the percent, so that's like what we're looking for. So what I would think about, we're like looking for that percent. So together they're 8 milligrams, and that's just getting the 1 and the 7 together, right? What you can do is you can say, okay, if it's 1 milligram, 1 times 0.8 is equal to 0.8, right, milligrams of platinum. Similarly, if you do 7 times 0.16, right, 16%, you get about 1.12, oops, sorry, not grams, milligrams. That's pure platinum. Which means if you put this and this together, that would tell you how many milligrams out of the 8 are pure platinum. So when you add those together, that's going to give you, it looks like 1.2. Excuse me. I looked at the decimal funny. If you add those together, it's going to give you 1.92. I saw that as 0.08, sorry guys. 1.92 milligrams of platinum. Okay, and that's out of the 8. So if I want the percentage, I'm going to do 1.92 over 8, and that can tell me what percentage is